In this video, you will learn about simple linear regression and how to conduct it on Excel. Regression analyses allow us to predict one variable based on the knowledge of a second variable. With regression analyses, it's really important that you're able to correctly identify the variables in the analysis. We have the y variable. This is the predicted variable. This is the variable that you want to be able to predict. And then you have the x variable, which is the predictor variable. This is the variable or variables that you are using to predict y. So returning to our copier sales example, we know that sales calls and copier sales are related or associated with one another. But can we use sales calls to predict the number of copier sales? A regression analysis can answer that question. And in this example, the x variable or the predictor variable would be number of sales calls, and the y variable or the predicted variable would be the number of copiers sold. So we want to be able to predict the number of copiers sold, and we're using sales calls x to predict copiers sold variable y. There are many different types of regression analyses. There's simple regression, which is what is covered in this video, and that's when we only have one predictor and one predicted variable. So we only have one x and one y. A much more common analysis is multiple regression, and that's when we have multiple x variables and one y variable. Multiple regression is more commonly used because you're going to be able to more accurately predict y with multiple x variables. So for example, we're going to do a much better job of predicting copier sales if we don't just use number of sales calls. We could do the number of years of experience the employee has, how many copiers they sold in the last quarter, how many copiers they sold last year. There would be multiple variables that would do a better job of predicting copier sales in comparison to just one variable on its own. However, when you're learning about regression, you first learn about simple regression, and then after you master that, you move on to multiple regression. You'll learn about multiple regression in QBA 2720. So for simple linear regression, again, the simple means that we have one predictor variable, one x variable. The linear means that the relationship between x and y is linear. So you must have a linear relationship in order to conduct this analysis. And then variable x and y are both quantitative. This analysis will, first of all, tell us if we can use x to predict y, and if so, it's going to give us an equation that will allow us to estimate future cases. So for example, we're going to conduct a regression analysis to determine if we can use sales calls to predict copier sales. If we can, the analysis is going to give us this equation, and then what we can do is we can predict how many copiers an employee will sell if they make 10 sales calls or 20 sales calls, or so on. In order to determine if x can predict y, we have to go through the steps of hypothesis testing. Regression is much more complicated than the previous hypothesis test that we learned, in the sense that there's actually potentially two hypothesis tests that you would have to go through. The first test is called the global test, so we'll start there. If you look on ISMS, you can see that I have posted a handout that details all the steps of hypothesis testing for simple linear regression. So step 1 is choose the appropriate statistical test. And our test is going to be simple linear regression, the global test. So we are going to choose simple linear regression, global test. And again, the steps of the hypothesis are the same. It's just how you complete each step differs from hypothesis test to hypothesis test. The second step is to identify the case. The global test is always a one-tailed right. So we are going to choose one-tailed right. The next step is to state the null and alternative hypotheses. The null hypothesis is that the x variables do not significantly predict y. Remember, the null hypothesis is always that whatever you're looking for isn't occurring. So there isn't a relationship, or you aren't able to predict why. The alternative is the research hypothesis. It's what we expect to find. And the alternative for the global test is at least one of the X variables significantly predict Y. So the null hypothesis, again, is the X variables do not significantly predict Y. And the alternative is at least one X variable significantly predicts Y. Now, this might be a little bit confusing because we only have one X variable, but the way that the test is set up is it's kind of assuming that you have multiple X variables. So we have to go through the steps as if we have multiple X variables, but really we only have one. The next step is to set alpha, and for regression, we're always going to use an alpha of 5%. So we are going to use an alpha of 5%. The next step is to compute the test statistic. And the good thing about regression is that we don't have to use a formula for the test statistic. We're going to run the data analysis toolpack, and the output will give us the test statistic, the p-value, all the information that we need. So I'm going to open up the data analysis toolpack in my data tab. And I'm going to select regression. The analyses are in alphabetical order, so regression's towards the end. And I'm going to hit OK. So the data analysis toolpack is going to ask for the Y variable and the X variable. And it's very important that you enter this information correctly, because if you accidentally switch the variables, all of your answers will be incorrect. So the Y variable is the variable that you want to predict. So we want to be able to predict the number of copiers sold. So I'm going to select that column of data, and I included the heading. The X variable, that's the variable that you're using to predict Y. So we are using sales calls to predict copiers sold. And again, I included the heading when I selected that column. I'm going to check labels in the first row. And then I'm going to select the output range, and I'm going to choose that designated cell. As always is the case with the data analysis toolpack, it's crucial that you put the output in the designated cell. And then I'm going to hit OK. I'm going to hit OK for that warning message. And this is what the output looks like. All right, so our test statistic, I'm going to reference the test statistic. It is right here, 10.87. And I'm actually going to write above it, this is the test statistic. The next step is to determine the critical values and the p-value. The critical values, Excel does not provide them, and we're not going to use a function or anything like that to determine that. So we're just going to skip the critical values. But Excel does provide the p-value in the output. So right here is the p-value. And again, this is for the global test. And again, this is for the global test. So I am going to reference the p-value. And we can format it as a percentage and show 2 decimal places. Now for the critical values, it's a one-tailed right, so we wouldn't have a lower critical value. Remember, with a one-tailed right, we only have an upper critical value, and we don't know that upper critical value because Excel is not going to give it to us. So I'm just going to put a question mark. You'll notice on the homework, I just won't include this information in the chart, so you'll just have to reference the p-value. The next step is to determine if we're going to reject or fail to reject the null hypothesis. Remember, there's the critical value approach and the p-value approach. Well, we can't use the critical value approach because we don't know the critical values. So we're just going to stick with the p-value approach, which many people think is the easier approach. So again, if our p-value is less than alpha, we're going to reject the null. If our p-value is greater than alpha, then we're going to fail to reject the null. So our p-value was 1.09%. And that is less than our alpha of 5%. So our p-value is less than alpha, so we are going to reject the null. So we are going to reject the null hypothesis. Next, we are going to write a conclusion. If we had failed to reject the null hypothesis, we would have just repeated the null. So we would have said the x variables do not significantly predict y. But in our case, we rejected, so we're going to state the alternative, at least one x variable significantly predicts y. At least one of the x variables significantly predict y. The next step is to conduct the individual test. You only conduct the individual test if you've rejected the null hypothesis in the global test. So when you reject the null hypothesis in the global test, you know that at least one x variable significantly predict y. So you move on to the individual test to determine which variables predicts x and which variables do not predict x. However, we're conducting a simple linear regression. So because we now know at least one of the x variables predicts x, we only have one, so we know that x predicts y. So we know that sales calls predicts copier sales, but we still need to go through the individual test because it's going to provide useful information. The difference between the global and the individual test will become apparent once you learn about multiple regression. However, learning about it now is going to set you up for a good place in 2720 when you conduct multiple linear regression. So again, we only conduct the individual test if we've rejected the null in the global test. So the first step is to choose the appropriate statistical test. And we're doing a simple linear regression and we're doing the individual test. So I am going to choose the option for the individual test. The next step is to identify the case. The individual test will always be two-tailed. So I am going to select two-tailed. The next step is to write the null and the alternative hypothesis. The null hypothesis is that the slope for x is not significantly different from 0. If a slope is not significantly different from 0, if it's not different from 0, that means it is 0. And I'll talk about what the slope means in the next video, so this will make more sense. But just for now, know that a slope of 0 means x does not significantly predict y. So essentially what we're saying with our null hypothesis is x does not significantly predict y. The alternative is the slope for x is significantly different from 0. So if it is different from 0, that means it does not equal 0. And what that means is that x does significantly predict y. So what the alternative essentially says is x does significantly predict y. So again, the null is that the slope for sales call, that's our x variable, is not significantly different from 0, which basically means it is 0. And the alternative is that it is significantly different from 0, so it does not equal 0. The next step is to set alpha, and just like the global test, we're always going to use an alpha of 5%. Next, we're going to compute the test statistic, and we don't have to compute it, we're going to locate it in the output. If you return to your output, you can see that the test statistic is right here. So I'm going to highlight it, it's 3.297. So this is the test statistic for the individual test. And I am going to reference it. And we are going to want to format it to 2 decimals. So it'll change to 3.30. And I forgot to format the test statistic in the previous one. I'm going to add a note to the video, but if you didn't notice that, make sure that you format the test statistic to 2 decimal places. The next step is to determine the critical values and the p-value. X is not going to give us the critical values, but it will give us a p-value. So we can reference that in the output. So again, we do not know the critical values, so we're not going to use those, but we are going to look up the p-value. So the p-value is, I'm going to reference it here in the output. It's right here. And I am going to format that as a percentage in 2 decimal places. And then I'm going to make just a note so you know that this is the p-value for the individual test. The next step is to determine if we're going to reject or fail to reject the null hypothesis, and we're just going to use the p-value approach, again, because Excel has not provided us with critical values. So the p-value approach, again, if p-value is less than alpha, we reject. If p-value is greater than alpha, then we fail to reject. When you're conducting simple linear regression, the individual test, the p-value, and the decision is always going to be the same as the global test, and again, that's because we only have one X, we only have one predictor variable, so they're basically the same test, but it's just a good habit to go through both the global and the individual because that's what you'll need to do for multiple regression. So our p-value of 1.09 is less than our alpha of 5%, so we are going to reject the null. So finally, we are going to write the conclusion. You can see that I have the conclusion for if you fail to reject and if you reject, we rejected. So we are going to conclude that the slope for X or sales calls is significantly different from 0. Sales calls does significantly predict copier sales. So the slope for sales calls is significantly different from 0. This means sales calls significantly predicts copier sales. So if you remember a regression analysis, first it tells us if we can use X to predict Y. So now we know X can predict Y. Sales calls can predict copier sales. So now what we can do is we can determine the equation to predict copier sales, and I'll cover that in the next video.